Hello.
Hey.
Abby, do you want to manage the breakout rooms for each other?
Yes, but I don't know if I've ever made breakout rooms before, so I
Okay.
actually was going to ask.
Yeah, it's not too bad. So I'll go ahead and create them. I think we made like 14 last time. Um, don't assign automatically, assign manually. So if you click on breakout rooms, because you're a co-host, right?
Yes.
Hello. If you click on breakout rooms, all of the rooms pop up and you just click on assign. And then it'll have a little checklist of everyone in the meeting currently, and it's alphabetical. So like if people have prepended their name with a group, you can just easily see where they go and they just want to be in a room by themselves. But then everyone else, yesterday I was putting around 4 or 5 people per room,
Okay,
and then the people in a specific group by themselves.
gotcha. Okay.
Okay, and then you just set the time. So I want to set it to 10 minutes, I think. Okay, and we can probably go ahead and start letting people in. Okay. I'm going to go ahead and admit everyone. Jesse, did you want to say anything at the start?
Yeah, I'll let people know about Friday session and
Okay.
that we'll be sending out the recording shortly. Welcome back, everybody. We'll be getting started in just one moment. We'll let people get on for just another few seconds and then we'll get started. Welcome back, everyone. Welcome to day 2 of our AI Winter. Wanted to let you know that recording is now available. I'll be sending that email out shortly, along with a summary of the first day session. Today, we're going to be taking a deeper dive into the models and into the architectures and other important aspects of the models. That's going to be Miranda Shirk that's going to be introducing you to those. And then we're also going to have Abby Petulante, who's going to be talking about diffusion models and how those fit in as well. Wanted to let you know that we will have a session on Friday. Friday is going to be an important day because we're going to be talking about some of the off-the-shelf solutions that you can have to create your own, what OpenAI is now calling GPTs. And the idea here is that using off-the-shelf components, you can upload documents, upload information, and create GPTs that allow you to solve problems without coding and without custom training your own network. So it's a powerful way of solving a subset of problems. And for some of you, it may actually be the complete solution for what you need. So we're going to be talking about prompt engineering. We'll be talking about creating the custom GPTs through OpenAI. And so that's going to be on Friday. And Shara Bell is going to be introducing those topics there. Also, so today again we're going to be diving more into the into models, and Thursday we're going to be talking about training your own models, because in some cases you actually want to be able to train your own model, not from scratch necessarily, but from a starting point. This can be because you have very specialized type of data that no model covers. It could be, for example, the medieval French, or it could be that you have some real sensitivity around your data. So you want your model to learn about your particular domain, but you don't want to actually be sharing your information with OpenAI or with anyone else. So on Thursday, we're going to be talking about solutions for that. Everything from running models on your, if you want to run a model very securely, you can run it even on your own laptop if you have a powerful enough laptop, or on your own larger hardware. And then we'll also be talking about training those models as well. So before we jump in for today with Miranda, any questions from yesterday or questions about what we're going to be covering next? All right, very well. And Miranda, please take us through deeper into models.
Okay, starting my screen share just now. Hello, everyone. Go into slideshow. All right, hopefully you can see my slides right here. Okay. Well, good morning or afternoon, whatever it is for you. Abby and I will be leading you today through a model overview on both transformer and diffusion models. So we will look at a little bit of a deeper dive into what we did yesterday, learning about transformer models and how they work, and then also looking at some specific models as well, so you can feel informed when you are choosing what model you would like to use. Okay. So first, let's start with these transformer models. And just as a review from yesterday, we discussed LLMs, or large language models, that are trained on a corpus of text, a large collection of text. And sometimes this is with self-supervised learning, such as masking, just like Jesse talked about yesterday, where you may have a sentence where you take out one word and have the model guess what that word should be. And that is how a lot of these models are learning how to generate their own text, is they're learning on a sentence and trying to guess a word that goes in the middle there. We can also have instruction fine-tuning, in which we're training the model to actually follow instructions instead of complete sentences, such as ChatGPT, which answers prompts instead of just completing whatever sentence you have input there. A lot of different methods for training on this large corpus. That text is then tokenized, as we discussed yesterday, which is just split into words and subwords. This tokenization is important because it allows us to still associate words like run and running together, even though they may be different versions of the same word. So ran, run, running, when we tokenize them, it is very similar to stimming, if you're familiar with that from way back in LP, in which we're allowing different words to be still associated with each other with the same meaning. Then we're going to convert these tokens to embeddings or vectors to represent some sort of semantic meaning. And if you recall from yesterday, when we discussed some sort of semantic space, if you imagine like a graph or a map,
And you want words that are very similar to be very close together, and words that are not so similar to be farther apart. So you can imagine some sort of space where we have royalty, and we want, queen and king to be around the words royalty, whereas some unrelated word, like computer or something, to be, off, not too far away, but not very close either. So when we're embedding, we're trying to get to this space so that we can associate our words with some sort of number that we can then find for later. And really the key to these transformer models is attention, in which we're using, or the model is using context clues to infer meaning. So if you remember the example with the time flies like an arrow or fruit flies like a banana, the flies in that can either be fly the noun or fly the verb, and attention is what allows those models to infer what we are talking about in those different sentences. So typically in this course, mainly, we'll be talking about generative AI. So when you imagine like ChatGPT or models that are generating text, we are going to input some sequence of words, so some sentence, and then we want the model to output a sequence of words for us. So just like if you're working with a chat model, like many of us have before, just interacting with it, you give it some sort of sequence of words, and the goal is for it to then output some sequence of words. So my question that we didn't really get to yesterday is there a limit? Is there a limit to this input that we can give? So I'm going to give you just a couple seconds to ponder that. You don't have to say it out loud, but you can if you would like. So is there some sort of limit to the sequence of words that we can give our model before it stops being helpful? I won't keep you on the edge of your seat for too long. That limit does exist, and it's called context length. So we're going to talk a little bit about context length in regards to what models we want to use. And yes, I did see someone's answer. Good job. Okay, so context length is that limit. It's the number of tokens that a model can take as input before forgetting prior tokens. This isn't a limit like a memory limit where it can't hold as much information. It's really more of that attention mechanism, how much it's able to pay attention to. So the number of tokens that a model can take as input before forgetting. So you can imagine yourself maybe reading a really long paragraph that takes several pages, and by the time you read through that paragraph and you get to the very end, you may have forgotten what the beginning of that paragraph was even talking about in the first place. Well, models with that attention mechanism, it makes a very nice analogy to that as well, where if you give a model a really long prompt, it will very slowly begin to forget what came at the beginning of that prompt as you reach its context length or its context limit. And this is a very important variable in model comparisons. One very famous example or infamous example of a context length being ignored or not paying attention to is the launch of Bing GPT, in which Microsoft put out their own version of a chatbot like ChatGPT, Bing GPT, and they gave it what's called a system prompt, which is basically just a prompt that goes before every user prompt. So you can imagine just an automatic prompt that gets injected before the user says anything. And the system prompt that they gave Bing GPT was, you are a very helpful assistant, you are polite, you respond to customers, very nicely, and you're very helpful. And what people found when Bing GPT first released was that if they made their prompt long enough to surpass the context length of Bing GPT, it would forget that initial prompt that it is a very helpful and polite assistant, and then start saying very rude things to customers, which is not at all what Microsoft wanted. So then they took it down and had to iterate on that a little so that they could avoid that context length error there. So it's very important whether you just want your model to remember that it's nice, that it's polite to people, or if you want your model to remember important information for it to answer your question. So context length, very important variable when you're looking at different models that you want to choose. Okay. So let's just look at what this context length means and how maybe you can find it. So when GPT really started to get attention, that was GPT-3 from the wider public. GPT-3, which is now legacy, but it had at the time a very long context length of 2,000 tokens. So you can imagine tokens, like I said, are words or subwords. So maybe, you know, this is less than 2,000 words, maybe 1,500 words, depending on how we tokenized them. So 2,000 words, that's pretty good, but it's not a whole book chapter. It's not a whole essay. So that was GPT-3. And now in later versions of GPT, so GPT 3.5 and GPT 4, you can see with GPT 3.5, we actually reached 16,000 tokens. Then with GPT 4, we reached 128,000 tokens. So a big leap in the number of tokens that we can accept. And then, of course, there's different versions of it where if you don't need that context length, you can use something like this. But the most recent GPT 4, I believe, still has this 128,000 token context length. This is just from OpenAI's website. So you can see here, you know, just the improvement in less than a year, I believe, from 2,000 to something like 128,000. And so that gives you a lot more prompting that you can give your model, a lot more instructions, a lot more text that you can give it. Just an example of context length. Yes, Bill, I see you have your hand raised. Bill, did you have a question? Okay. Bill, you can go ahead and ask your question if you would like. Hopefully you're able to unmute yourself. Otherwise, you can put it in the chat. Oh, cannot unmute. That's very strange.
Yep, it is allowed now. So go ahead.
Okay. Thank you for letting me know. Okay, Bill, you should be able to ask your question. Sorry about that.
And in chat, Bill asks, does context length include the response?
Oh, that's interesting. So context length is, and correct me if I'm wrong, just for the prompt. So, well, does it include
It's
the
actually
response as well?
Yeah, so it's going to be.
Oh, well, because it can include when it's responding. It'll forget what it's responding if it
exactly
surpasses that context length.
Yes, that's right.
Okay, still cannot unmute. I'm sorry, Bill. I don't know why that is. But yeah, so you have a context length for your prompt. But with context length, that is also how much you can pay attention to while it is responding as well. So it does need to remember that question and then keep that in mind as it outputs its answer as well.
And
okay.
Kendra Oliver has a question. How did they do that? How do you extend tokens amount? What is the limit?
Ooh, that's a very good question. And there are a couple of different methods that they do. Jesse might know a bit more about this than I do. Jesse, did you
want to answer first? You want me to?
So I know you can do different kinds of like multi-head attention and different methods to increase the context length, but I think sometimes they don't always say, is that right?
Right. So especially with the commercial models, they really don't share exactly how they are doing these things. But attention is the most computationally intensive part of all of this. It grows, you know, a power of 2 and more depending on how you're doing it. So you can only get so long before you run out of compute and out of memory for it to tend to everything all at once. So one way is you can use sparse attention. So not everything in your context gets the same attention. So you're not averaging all the different tokens. Tokens that are further away don't influence as much the token that you're at. That's one way. And there are other computational tricks as well. So there are really only 2 models right now that have those long context lengths that we know work really well. GPT-4 and also Claude has 200,000 token length. But we're probably getting to the edge of what's useful. But boy, you're pulling every trick out of the hat in order to scale that much.
Also great questions. Any others? All right. Bill, you do still have your hand raised if you have a question, but that may just be a lingering hand. Okay, well, great. So context length. And to summarize, this and then also what we've been discussing yesterday, how these models can differ, what you may want to look at when you are choosing a different model. Context length is one. Do you need it to have a long context length? The size or number of parameters. This is especially relevant if you're wanting to run a model locally on your own machine, or if you want to consider, the cost of cloud computing. Training data, what kind of data was this model trained on? So actually, I believe their Midjourney has just recently come under fire for knowing which artist. So Midjourney is a model that can produce images, so like AI art, and I believe they just recently came under fire because they had originally claimed that they didn't know exactly which artists they had trained on because it was freely available art. There was no way to keep track of that, but I believe they've recently been caught with a comprehensive list of all of the artists that they have taken art from, which is a pretty big deal because that was without these artists' permission. So what data was your model trained on is a very important question. ChatGPT, for instance, does not release its official training data. It just kind of vaguely says freely available information on the internet. So you can imagine, stuff like Wikipedia, but you can also imagine, forums or various sources of not great information that it might have come from. Other open source models do release their training data for transparency, which is very nice. But it's definitely something that you want to consider with your model. Because that training data really influences the biases, the responses that you're going to get from your model. So sometimes you can imagine, what is maybe the average idea of whatever this concept is that I'm wanting to ask about, what's the average idea of that on the internet? And that maybe gives you, an idea of how reliable that information could be. And then also the training method. So does this have instruction fine-tuning like ChatGPT, in which it's not just completing your sentence that you're giving it, it is actually answering a question or following instructions. Reinforcement learning with human feedback is a way to have humans look at responses that your model gives and then say, if that's a good response or not. So when models are very polite, like, certainly I will help you with this, that is something that sometimes comes from what we call RLHF. And then just this ellipses contains the multitude of other things that you might want to consider depending on your project. So these are some of the main ones, but you can imagine there are a lot of different other variables that might be just specific to your project. So I like to think of, the best model for your project. Really, you need to consider all of these variables here, context length, the size, the data that it was trained on, and the training method, as well as any other project-specific considerations. Maybe you need to use audio data. Maybe you need your data to be private, so you have to run the model locally. And in that case, that affects the size of the model that you can use feasibly. So all of these go into choosing, that best model for your project. Okay, are there any questions in the chat that we saw? Oh, I see JPB, you have your hand raised. Okay, it looks like people are having trouble. Oh, here we go. All right, it should be fixed. You should be able to unmute yourself now. I don't know. Some people are able to unmute and some people are not. JPB, do you have a question?
And JPP is actually putting it into text. He says, so just out of curiosity, how big are the spreadsheets of the model?
The spreadsheets. I am not sure what that means.
If you're talking about model size, the size of the file with the weights. So this can range anywhere from, we usually talk about, I jumped right in because I was talking, Miranda. I'm sorry.
Oh, go ahead. That's totally fine.
Okay. So you do parameter count, right? And so you have like smaller open source models are like 7 billion parameters. up to 1370 billion. But if you think about each of those 70 of each of those 7 billions is a float. So you're talking about, 7 gigabyte, a couple of 100 gigabyte up to many, many gigabytes or even terabytes for the largest models all told. And that's why only the smaller models can you train on GPUs, because it all needs to, generally, all needs to fit in the GPU at the same time. So you're talking about model weights in the model architecture, weights being the far larger of the two files, being anywhere from, with the smallest models, maybe a couple of megabyte up to gigabytes and terabytes for the largest.
Awesome. Great questions. Okay, and just to clarify what we'll be discussing today, so we're largely focusing on this red portion, the right side of this diagram here, focusing on decoder or generative AI. Those are the AIs that are putting out text for us, not necessarily categorizing them or anything else. We want, sequence in, sequence out type of models. And this diagram is a bit old, way back in 2022, and has not been as filled out on this side, but you can imagine all of the models that have come since then. This side is what we'll be focusing on, generative AI. And another little diagram that I like here is just kind of a timeline of all of these models where they have been. And again, ends just a little bit after 2021. So a little old, but I do like seeing this on, where all these models came into being and which ones maybe influenced future ones as well. Okay, so let's go ahead and get into the models. I'm going to check chat real quick. Okay, looks like a question for Jesse on there. All right. So just as an overview of the models, we're just going to go through some of the common models you may have heard of, some important ones, answer any questions that you might have about them. And then we're going to do an exercise towards the end before we go on to transformer models. And I do see a question here in the chat for images. What would the context length be and how can you surpass it? So with images, you can imagine the different pixels, however you encode those pixels as being your sequence there. So it does get a little more complicated to maybe think about offhand how large that would be. But you can imagine, a sequence of pixels at its basest. And then, however large that image is or how much resolution you have in that as being the context length. Okay, so just to start off with one of the most popular ones, we have ChatGPT 3.5 and 4. So 3.5 still in use. Some people still use it because it does have a pretty good context length and widely available. It's a little cheaper to use, I believe, than GPT-4. So ChatGPT 3.5, we've got 175 billion parameters. So that's like what Jesse was saying earlier, and with our question before about, if we put those parameters into some sort of file, how big would that file be? Well, you have 175 billion numbers, which is quite a lot. The context length on 3.5 is 16K. This is as of their website this week. So hopefully nothing has changed since then, but I got this from OpenAI's website. And then their training data, they widely just say is freely available information on the internet. Very vague. They don't release what that information is. And, a little vague. RLHF, both of these models were trained on. One thing that I want to point out, ChatGPT-4, they have not actually released a lot of information about GPT-4. It's a little bit of a mystery. So we don't know the size. We're assuming it's larger than GPT 3.5 just because it has so much more capabilities. It is a very good model. So we're guessing a greater than 175 billion parameters, but no one really knows. The context length reported to be 128,000 tokens. And again, the training data just on the internet, a little bit additional training data, I believe, than 3.5 would have, but no one really knows. It's pretty secretive on that. So really great capabilities for ChatGPT 3.5. It's very ubiquitous. A lot of people can access it. You can go to OpenAI. You can use it in APIs. You can use it in the actual chat window. And I'm sure a lot of you have already heard of ways that people use this for brainstorming ideas, summarizing documents, hopefully not doing homework. Although that is known to happen sometimes. Also, one thing that GPT-4 really revolutionized was UI design, user interface design. So I am more of a back-end programmer. I'm not a user interface person. And one thing that I love about ChatGPT-4 when it came out was I could sketch up an image, do a little sketch of what I wanted a website to look like maybe, and then upload that image to GPT-4, and it was able to give me code that would make that user interface look the way that I wanted, which is gorgeous. I love that. I don't want to mess around with JavaScript all that much. So that was great. I haven't tried that recently, so I'm unsure if that is still a common use case. But I used it pretty recently. So, GPT, we've all heard of this one. Another notable one is Claude. This is by Anthropic. The most recent model that they have out is Claude 2. Before it was just Claude. 52 billion parameters, so not quite as large as the GPT models, but notice this context length, 200,000 tokens. That's pretty amazing. And before GPT-4 came out, it's still larger than GPT-4. So very, very impressive. You can put a lot of information into Claude. It can give you a lot of information back. So you can imagine, maybe very creative tasks, a lot of brainstorming, ingesting entire scientific papers and, outputting a summary of those. Very nice. They also have not released their training data, but they do say that it is a mix of freely available information and also licensed data, which is very nice. They have paid for some of that data as well. So not just freely available information and maybe, some scraped stuff, but also some sort of package of licensed data that they don't disclose. So like I said, with this context length, very great for long context problems, reading entire book excerpts, papers, anything like that. Okay. And another one that came out of wanting an open source model. So before we've been talking about Claude and the GPT models, OpenAI, those are not super open about what their training data is, what their model, how their model is constructed, and you can't really run those locally. But with Llama, that came out of, I believe, Meta wanting to provide an open source model. So it comes in various versions and sizes. The first one was just Llama, 7 billion, 13 billion, and 70 billion parameters, depending on what your machine can run. A pretty small context length, however, of just 4,000 tokens. But they do disclose they have some sort of mix of publicly available online data. I am unsure if you can actually find this data. You might be able to, but just from my research yesterday, they do say that it's publicly available. And then after Llama came Code Llama, which was actually trained on, it says 500 billion tokens from a code-heavy data set. So this is very exciting, actually trained on code completion, so that Code Llama can actually, do code completion, or you can give it a prompt and it will code something for you. Really cool to have an open source model directly trained on code. And very similar to Llama, it has a couple different sizes, but a much larger context length here. And then one that we briefly touched on yesterday after someone asked about mathematical thinking or models doing math is Lemma, which is a little bit more recent, only has one size, 7 billion parameters, just 4K context length. But I think this is so cool because it was actually trained on a data set called Proof Pile 2, which is a compilation of proofs, mathematical reasoning, mathematical operations. And so it was actually trained on this giant data set, I believe using masking, and is capable of writing proofs and doing some more mathematical reasoning, which I think is so cool. There's a paper out if you'd like to read it. I do have all of the papers for these models if you're interested in receiving those as well. So Llama, very nice. Like I said, local inferencing, it's really great for. So if you have data that is private, data that you don't want to send to OpenAI or some other company, you can use Llama locally, which we will actually go through, I believe either tomorrow or the following day, on how we can do that local inferencing. Code Llama, very great for ingesting code documentation. I mean, a pretty long context length. You can imagine maybe a lot of legacy code that you have written by someone else or some package or something, giving as much of that documentation as will fit into Code Llama and having it understand it and then be able to tell you how to code something or give you the code itself. super useful for programmers. Code completion and generation, GPT-4 does do coding, but Code Llama, like I said, is you can run it locally, and it was actually trained on a very code-heavy data set. Whereas GPT-4, most likely, freely available information on the internet that makes me think of Stack Overflow or other tutorials, on Python and stuff. So maybe not as reliable. You do have to watch what GPT-4 gives you sometimes. And then mathematical reasoning with Lemma. So very, very cool. Another newer one, Mixtral, and another very similar named one called Mistral. But Mixtral stands for mixture of experts model. And one thing that's interesting about this one, I put size is 12 billion of 45 billion parameters. That is what's on their website and on their paper, because they actually have what's called a mixture of experts, where you can imagine maybe different partitions, for lack of a better word, of the model, in which a question gets passed to the part of the model that can best answer it. No, that's wrong. I see Jesse shaking his head. Oh, okay. Okay. I thought you were shaking your head. And so they have a mixture of experts in which, you're not using exactly all of the parameters at once. It's kind of allows itself to specialize in different areas, so to say. Like I said, all of this is, pretty abstract. So I'm trying to bring it down to a level that we can think about, but it only uses about 12 billion parameters at one time, which is kind of its selling point that they like to say. It has a lot of parameters to use, but only about 12 billion of those get used during computation. Context length 32K. And again, data extracted from the open web is its training data, like a lot of these models as well. The most recent version of Mixtral is capable of using English, French, Italian, German, Spanish. I believe that's just it. And then it also is good with code generation. So Jesse, did you have anything additional to say about Mixtral?
No, well, Mistral is brand new, very good performance. So it's really the first open source challenger that we've seen that has some of the same capabilities as a GPT-4. In short, very interesting times.
I have not had a lot of chances to play around with Mixtral, so I'm really excited to get into that. I encourage you to look it up as well. Okay, and then Whisper, which actually Charo is going to help me out with because she has used it extensively. Charo, did you want to talk a little bit about how you've used Whisper?
Sure. So Whisper is another type of model. It is an audio model in particular, mainly doing speech to text. And so what that means is there are actually two parts of these models. Yes, it is generative, as Miranda said. It has that decoder part that helps with the to text part. It also does have that original encoder part. You can see this in the image at the bottom, where it does have like the two pieces of a transformer instead of just the one. So we have the encoder, which does the speech kind of encoding part, and then the decoder, which does the generative AI part, bringing that speech into the actual text. So Whisper is available through OpenAI, and it was created by OpenAI. You can use it directly through OpenAI, so they have their own way of accessing it. It is also, so the model weights are actually freely available. You can download them yourself and work on it locally, which is a major pro for it. It also has several different sizes, including Whisper Large noted here, but it also has several other smaller sizes. The context length is something interesting about Whisper, depending on how you choose to use it. So which API, OpenAI versus a more open, so essentially Hugging Face transformers. With Whisper, you can feed in context or audio that is very, very long. What it does is it essentially will split up that audio into 30-second overlapping chunks, and then it will process your data that way. So technically, the context length would be 30 seconds. It's just that it's able to do additional processing to help you just be able to pass in a very long audio recording, and then it will do that chunking for you. In terms of the training data, as Miranda has said, it's just these audio transcripts. So these paired transcripts where you have the audio, so you have the speech alongside the actual transcribed text. Something that is super interesting about Whisper is that it was trained by large-scale weak supervision. And that may be interesting to people who are trying to do some type of like signal training. So whether it be like LIGO or whether it be different kinds of speech. The thing about this training was that it didn't use specifically a gold standard sort of training set. So in general, when we think about training, we think that essentially the input and the output of the training data must be close to perfect. Whisper relaxed this constraint specifically because there wasn't that large availability of golden standard speech to text training data. And so now we have instead adding in some less gold standard data, which also resulted in a model that is actually still yet very, very capable. So that is something that if you're training like your own model, that's something to consider. If there is no or very limited training data that is gold standard available to you, you may be able to relax that constraint of it being close to perfect and also achieve some good results. And in their paper, do look at how they actually did that. It wasn't that they were just using like this sort of trash data. It was very well groomed. It just wasn't absolutely perfect. So again, Whisper is going to help you do speech to text. It does a really great job. You can use it locally. You can use it specifically through OpenAI. It has a number of different sizes. It works in a number of different languages. Beyond just direct speech to text, it also is able to help you with something called speaker diarization, meaning that if you have multiple speakers in your audio, it can help you separate the individual speakers into their own individual tracks, if you will. It can also help you with audio or speech activity detection. So identifying when exactly people are talking in your actual audio. So interestingly enough, this is a very powerful model. There are other types of audio models as well, such as wave-to-vec2 or wave-to-vec2 phoneme. And so again, as Miranda has so well described, it's very much dependent on what you want out of this model and what you're trying to do with the model, always keeping in mind that these are very much based on sequences. So even if you don't have audio, audio is a signal. And so when you're thinking about using signal data, you can always think about using and inspecting those audio models for how they're doing whatever they're doing.
Great, thank you, Sharo. I think Whisper is so cool. It's been so cool to see our team begin to use it. I will be starting to use it this semester as well, so very, very excited to jump into that. All right, so that is mostly what we wanted to talk about with these models today, and we have a breakout exercise just for you to do to kind of ingest this and then maybe think about, you know, the possibilities with your projects as well. So if someone can mute that.
Now on Monday, just 3 days later, it shows that the account has lost $210,000 in one trading day. He quickly picks up the phone to call his best friend, who's also a local stockbroker.
Okay. Sorry, that was strange. It would not allow me to mute that person. Okay. Okay, anyway, apologies for that. I was unable to talk with extra audio signals coming to my brain. Okay, so we're gonna go ahead and put you into breakout rooms. Abby, were you able to get those up?
Yes, I think they
Okay.
should be good.
Awesome. So if you scroll down, we have the breakout room document, which we can put in the chat. And if you scroll down, we have day 2 up at the top here. So just within your room, I want you to discuss, you know, what qualities would you need in a model for your application, or if you don't have a specific application yet, maybe your ideas. You know, I'm asking you to consider what we talked about today: context length, maybe data privacy, model size if you're running it locally or in the cloud. And then, you know, what models, have we discussed any models today that would work well for your project, or maybe you know of some that all that we didn't discuss today that you would like to learn more about. So we'll go ahead and send you to those breakout rooms. I do see some of these questions come in, so I will look at those while you're there and then answer when we come back, I think. Okay, awesome. So if we're all ready, then you can go ahead and we can open those breakout rooms. Yes, and I'll put
pause for
Google
one quick
Doc.
moment, and I will put let's put the Google Doc back in the chat so they can add. There we go. Brilliant.
Yep, there it is. Okay, so hopefully everyone has time to click on that.
Abby, are you opening up the rooms?
Yes, sorry. Okay, I will open them right now.
Awesome, thank you. Thank you for catching all those questions in the chat.
And folks who are back here, do you need help getting back into your rooms? Efrat or Kendra?
Yeah, I'm trying to find my room, but I don't know where it is. Oh, I found it. Thank you.
Sorry, I'm in the middle of something, so I won't be able to do the breakout activity. So I just am hiding in here. That's okay.
That's fine. Actually, oh, Kendra, it was your question. You had the question, this is probably related to a discussion of multimodal training. Why we train models on code be better? So the idea here is that all models been trained on some coding, but if you train specifically on coding, then the model is, and computer programming, it's better at solving more complex problems. So you can find some real differences, like ChatGPT wasn't explicitly trained extensively on coding, and it's okay. It can solve basic ones, but whenever you get anything more advanced, it doesn't do it very well. GPT-4 probably had, specific training, but then you have things like Llama and Code Llama, and now Mistral and a few others that got specific training on coding, and they are terrific at programming. They're as good as GPT-4, which is an order or several order of magnitudes larger, larger numbers of parameters. So what we're learning is targeted coding, targeted training is matching and in some cases beating extremely large models. So it's turning out that training, how you do the training, curating your training examples is important. Same thing with coding. If you're careful about how you train it on coding, give it clean examples, good examples, then it's able to learn and to generalize much, much better to new examples.
Okay, I think everyone is back now. All right, so just taking a look at this breakout room document, just kind of want to see what some of the rooms discussed. So room 5, what were some of your takeaways from this exercise from the models? Oops, do we have a volunteer from room 5?
Well, I was doing the typing. So Alyssa or Fundia, if you want to, chip in here as well, I would appreciate it. But I think the gist of our conversation was about qualitative research and how these new models, I think we were talking mostly about Whisper, can be really helpful in catching the easy to miss moments of qualitative research. Alyssa, I think you mentioned it can be extremely.
No, I was saying kind of the opposite, actually.
Oh,
Sorry.
never. Go ahead. Yeah.
No, we were talking a little bit about when your goal is not document summarization or comparison, but catching sort of unique moments and catching lots of specific ones. This is what Jesse and I were talking about in a sidebar, ways in which the way the larger documents you upload might get, chunked and fingerprinted and then indexed and brought to bear or not is incredibly important. And I think that really exploring different ways in which this is done, which it could be done. We were talking, Jesse, a little bit about ways in which you might think about forcing the chunking a little bit automatically by how you actually conduct an interview and how you upload the data. And I think that it's obviously the privacy piece comes in as well. We're not just uploading this anywhere, but those context pieces I think could be really interesting to explore. Melissa, maybe we talk later.
And I'll just put a note out there too. We're going to be talking Thursday or Friday? Friday, of if you want real control over that, you can roll your own, you can code your own GPTs, your own assistants to do that. But another thing that I mentioned in the chat was also working with just the long context models. And there are some open source long context models. We haven't experimented to see how good they are, but putting everything into context, you don't lose anything. You're not dependent on that chunking and finding the right, retrieving the right part.
Right. Yeah, that's really fascinating. I love that you had this discussion because it is something that we found with RAG or retrieval augmented generation, where you put in something and you want to be able to search for it, but small things like that, like you said, maybe a pause or some sort of gesture or verbal tick, it doesn't exactly show up in that depending on how you chunked it. So we also had a similar problem in one of our projects where we were trying to use RAG on papers that were very, very similar. They were all on the same topic. So, or very vague. They weren't super specific, just in general papers. And it was having a really hard time answering our specific questions. So that's great. And then I see Melissa says that they were talking about the same thing in group 8. Would anyone in group 8 kind of want to relate what they were discussing?
I can just say we were also talking about qualitative data analysis and engaging students and thinking about the ethics of generative AI. But with respect to qualitative data analysis, I mean, the chunking, well, Alyssa and I are on the same dissertation committee, so it came up in there as well. But this notion of like a time-based chunking is like kind of antithetical to the way a lot of discourse analysis happens in qualitative analysis. So we were just talking about that. And then I was wondering about to what extent there are models that actually can look at video data. That's what because that's the kind of data that I have. But we were really thinking about the ways that there are some disconnects between the way a model might be trained and the goals of a model and the ways that qualitative researchers are trained to think about data and context and how to get those two in conversation.
Mm-hmm. Yeah, I think it's very important to have a lot of input from different experts from different fields, not just, maybe science or computer science people weighing in on these models, but also how they can benefit other fields as well.
I'll put in there too that
Mhm.
actually this is an active area of interest for us as well. So we're working with a Peabody researcher who does qualitative research and has a very large number of categories and going after getting information out of interviews. So we're looking at the utilities of these long context models so you don't have any chunking whatsoever. And then a separate question is, yeah, the audio, there's a lot of rich information in the audio that's not captured in text summarization. Same thing with the video. Video models are just now coming into their fore as the contexts are getting longer and you're able to analyze the video. I think we're going to start seeing some really interesting multimodal models that have text, audio, image, and video. And I think that's going to be a real important piece for that type of qualitative research. It's going to be an exciting time.
Yeah, could keep going on this topic. I really appreciate all of these comments. And then I do see a question I did want to address real quick. In the chat, who owns this data if you code your own ChatGPT assistant? So we probably will talk more about this on Friday, I believe, when we look at coding your own ChatGPTs. But as far as privacy of the data, who owns it, data ownership is very weird right now, sometimes with these models. But with ChatGPT specifically, if you're using their API, they technically have your data. You are sending it to them to analyze in some way, to embed in some way, unless you have your own enterprise version set up, which I believe Vanderbilt does or is working on it. But as far as making your own ChatGPT assistants right off of their website, you can, I believe, check a button maybe that says, please don't train on my data, but that doesn't necessarily mean they don't receive the data. So not really recommended for something where privacy is very much a concern. Awesome. Thank you so much for this conversation on different types of models and considerations. I really loved it. I hope you found it as fascinating as I did. Next, we're going to move on to Abby, who is going to take us through diffusion models, which we have not talked as much about, but I'm really excited for.
Yeah, okay. Do we want to perhaps take a 5-minute break in between these sessions? Okay. Yeah, so I think let's meet back here at 12:05 CST. Just take a short break and then we'll get started on diffusion. Oh, I'm sorry. I've been muted for the last 20 seconds. I was going to say that it looks like it's time 1:05, or I'm in Eastern time, so 12:05 if you're in CST. Can everybody see the screen okay? Cool. Okay. So yeah, as Miranda said, we are going to move on now to talking about diffusion models, which is really kind of another class of generative AI models that is typically used for image generation. So more generative AI, but in this case, generating an image, which probably you have seen instances of before, but I wanted to just kind of start by showing some AI generated images in case you kind of haven't seen this type of thing or you're not familiar with it. So here, this is GPT-4. GPT-4 has kind of within their chat logs on OpenAI integration with DALL-E 3, which is also OpenAI's image generation model. And so this is kind of just my personal favorite way to interact with an image generation model, just because it's so simple. But there are lots and lots of options for models, and people generally like different generative image models for different things. People have preferences. So this is by no means the best, but I just kind of like how I can go into it in the same chat logs that I'm already using to talk to ChatGPT about all sorts of other things. But here is just a few examples of images that I have generated. And the idea behind image generation is that you have a prompt and it generates for you an image that matches the prompt. So this was an incredibly simple prompt, an image of a lake in a forest. And it generates for you an image of a lake in a forest. I asked it to kind of iterate on this in a couple different ways to make it an impressionist painting, I think, to make the colors a bit moodier, and then to limit the color palette. But you can make all sorts of images. So here I made a long cat in pop art style. You can make more realistic images of, the universe, a picture of the universe. In this, I actually was trying to sort of test its ability to do more abstract concepts. So I wanted an image of the vast infinite beauty of the universe, which is a little bit of an abstract concept for an AI. This was the first image it gave me, which I would say looks very crowded. If you know anything about space, it's really not that full of stuff. So kind of exploring its ability to do different kind of conceptual things. So those are just a couple of examples of sort of images that you generate. The idea being with all of these that I am giving a prompt, and from it, I am getting an image. So I'm going to start by talking a little bit about kind of how these models work, hopefully at a high enough level. I don't want to get into like all of the weeds, but then talking about kind of what specific options there are for these models. And then we'll do a breakout room where you guys will play around with prompting a little bit. And I would love to kind of hear your experiences with prompting these models, because it truly is a bit of an art form, writing a good prompt to get a good image. So jumping into kind of how these models work. And I actually can go into slideshow now because I'm not going to tab over. So jumping into how these models work a little bit more. The basic kind of concept behind all of these models really has to do with noise and what noise does to an image. So here's an example of an image of a cat that I have I haven't, I took this image from somewhere, that they have progressively made more noisy. And really what noising an image does is that it covers the finer details. So in the first image, you obviously have a cat. In the second image, you probably have a cat. In the third image, maybe most people would tell you have a cat, but maybe other people would tell you that could be like some other animal. Maybe it's a dog. But the point is that the more that you add noise, the more you kind of remove specific details, but preserve a bit of being able to tell what's there. And so kind of the fundamental technology that diffusion models build on is, well, what if I asked a neural network to remove the noise and return the image to what it was? So really this concept is denoising, which you'll hear talked a lot about in diffusion models, which is that you want a model to learn to remove noise from an image and to create what the original image looks like from a super noisy field. And this is usually done, as I'm sure you can imagine, in an iterative process in these diffusion models. So you don't just straight go from like this noisy thing to a beautiful picture. You do multiple steps where you're removing a little bit of noise every time. And the model is trained on real image pairs of an image and noise that was added on top of it. But the beautiful idea behind that is once you have a model that can reliably remove noise, you can just give it noise and ask it to carve something out of it. And it'll do a good job of carving out an image of what was pure noise and didn't have some sort of underlying thing underneath it. And then of course, because this is generative AI and we're also wanting to generate certain looking things, we can condition that on text that says what we want the image to look like. But we'll talk about that in a second. But this concept of denoising a noisy image to create a real image is kind of the underlying fundamental concept of all diffusion models. So I'm going to talk specifically today about latent diffusion. Latent diffusion is, I mean, every model, as with language models, has kind of its own twist on how it does its generative AI, but latent diffusion is a really popular way to do diffusion and to generate these models. So we're going to hone in on this a little bit more specifically. And really, there's three kind of primary components that make up how latent diffusion works. And we're going to talk about each of these. So the first thing that you want is an autoencoder, which is really just a model that takes something, squeezes it down into a smaller something, and then is able to return it to that same original something. And we'll talk about why that's important. And I'll show you a little bit about what that looks like, but that's component number one. Component number two, I would say, is the meat of any diffusion model, which is a UNet. And this is the thing that's fundamentally doing that task that I talked about, which was denoising an image. So taking a noisy image, taking a noisy image and removing the noise in order to get the real image back out of it. And then, of course, as I mentioned, ideally you have a text component to this so that you can say what you want to carve out of the noise. So here we're going to talk about the inclusion of a text encoder kind of into this pipeline. So first, I'll talk about what each of these components is, and then we'll talk about how that kind of all fits together to create one of these models. Okay. So firstly, we have the autoencoder portion. So as I mentioned, an autoencoder really, its goal is to take an image, turn it into a low dimensional representation of that image, and then just blow that back up into the original image. So ideally, the input and the output of this are exactly the same during the training. So you really just want to, the goal here is actually really to be able to chop off this beginning section and just get this end section. So if I have any little dimensional representation of an image, I can turn that back into a larger version of that image. And latent diffusion really kind of relies on this concept of being able to work in that lower dimensional space, in the latent space, really well. So this is kind of a simple network. You can train it just as its own component of image to image, and then kind of take this useful part from that. Okay. The second portion, which, like I said, is sort of the bulk of what's going on in a diffusion model, is this UNet portion. So here we're starting with that noisy image and we're turning it into this real image. And like I said, we do this during training with real images that noise has been added to. So you do have a true underlying image that exists in the noise and noise that you have added to that image. And the goal of this unit is to iteratively just subtract an amount of that noise and slowly carve from a noisy image a real picture. And then the final thing that we're going to want to do is, of course, add in text. So if we have a prompt, we've already talked about how we can turn that prompt into a set of embeddings, a set of meanings about the words in that prompt. And so we can actually make use of that, this embedded version of our text that is very useful, and insert that as well into this model. And that means that as the model is denoising, it also has this additional context, which is what the image is supposed to be of. And again, during training, you can get images that have captions to teach the model kind of what denoising while conditioned on a caption sort of looks like. So then we are going to talk about putting those three components together. So those are the three kind of main things that make this up. And this is kind of roughly how that will go. So here we have the user prompt. So you input a text prompt that gets encoded and you have some set of embeddings. When you want to generate an image, you can start with noise. So you create just a thing of noise, just a little square noise. That goes through that unit. So it goes down to the bottom of the U. The text embeddings are added, so the model knows what it's supposed to do with the text and what it's supposed to do with the noise. And it turns it back up into another 64 by 64, in this particular case, can be different sizes, that has less noise than that original and has included in that text. This process is done iteratively over a number of steps until eventually this outcoming image is a lower dimensional representation, but of a real image, of a good image, of not just noise. Then finally, that variational autoencoder decoder that we talked about gets put through. And so this 64 by 64, which exists in the latent space, will get blown up into your final image, in this case, of an astronaut riding a horse. Are there any questions at this point about how this kind of pipeline all works together? Okay. Oh, yes, hand raise.
Hi, I was wondering what is the purpose of the autoencoder? Like whenever you're doing the reconstruction, it works better if it's in this latent space?
Yeah,
Or
that's a great question. I think that, yeah, so the VAE is really there because you're working in this latent space and you have to turn that resulting image back into a real image. So kind of a non-latent space-based diffusion model could kind of just contain this part. I think that the majority of the reason for working in the latent space is really just about that this is a computationally expensive process, and working on an image that's much, much smaller makes that easier. Yeah, I don't know if there's I don't know if it's been shown that necessarily images are better if you do them in the latent space. I think it's just that it's about kind of reducing the computational cost, and this works super well, and it saves you a lot to do it this way.
cool, thank you.
Mm-hmm. Okay. So those are sort of an example of how the models work. But of course, what is interesting is the models themselves and playing around with them, because they seem really simple when you lay it out, but they just like are so incredible. It still blows my mind every time that I use, especially one of these kind of recent models like DALL-E 3 or Stable Diffusion XL. They really just like are incredible, the images that they make. So this is a couple of examples. I know that a lot of these are available through other avenues. So if you are aware of a way to like get these things not paid or something, then feel free to drop it in the chat if you have questions about it, or when you're in your breakout rooms, kind of share that resource with people, because some of these you can get through a lot of different ways. Some are more proprietary and kind of locked up, and the company who made it doesn't want anybody to access it. But these are a couple of different options. So DALL-E 3 and DALL-E 2 are through OpenAI. DALL-E 3 is kind of, as with GPT-4 over GPT-3, it's like they're much better model. And so the images through here are really impressive, but DALL-E 2, you can just kind of buy credits. I think that DALL-E 3, you can only access still through ChatGPT, but that might have changed since I've last looked at it. Midjourney is another incredibly popular one. People kind of like that this seems to be much more creative, I would say. People think that this creates very like artistic, very interesting images. Stable Diffusion, I think, was kind of one of the earliest ones to kind of come to light and be super good, and people to really like it. So Stable Diffusion XL is their most recent version, which again creates really great images, and you can access some number of image generation through Dream Studio. ControlNet, we can talk about if we have time or interest towards the end. It's a really cool particular version of an image generation that instead of just generating the image out of like nothing, so I mean, it fits the prompt, but it really could be anything. ControlNet is really specifically constrained by either like an edge map or they have lots of different ways of constraining it through pose estimations and stuff. So it's structurally constrained image generation, and it's incredibly cool if your image needs to have like very specific structural constraints within it. So again, we could talk about that more if people are interested in that. But really what I want to get to is a breakout room so that you guys can kind of try this out yourself. Because like I said, the prompting of diffusion models is truly kind of an art form. It's very nuanced. Some images are just like hard to get the model to create exactly what you want. And the more detailed of the thing you have in your head, it's simultaneously the better because the model likes details, but it's also can be difficult to get it to create exactly what you want. And so I kind of made this note here that although that text component kind of seems small, like in that big kind of putting together all these components, we just kind of like stuck it in there. You have to remember that that's kind of all of the information that the model has about what you want at the time of generation. So highly descriptive, precise prompts can lead to the best results. But certain kind of words or certain descriptions can be more useful. So in the breakout room, I put in the breakout room document two kind of free ways to access some of these models that you should be able to just kind of jump into right now. But if you have access to anything else, like if you have a GPT-4 subscription or something and you want to use that, feel totally free. But basically in the breakout room, have something that you want to generate and just iterate and see what it takes to get a good prompt. And please share kind of what you find is necessary for you to get exactly what you wanted. And then if you have time during the breakout room to try out more than just one of these models and you want to note any particular differences that you found between the two of them or additional ones that you're able to use, that would also be great because I love to hear people's kind of experiences with what they think each of these models is good at. So yeah, before we hop into the breakout room, are there any questions? Okay, I'm gonna just post this in the chat one last time in case it's kind of gotten far up there since you last clicked on it. And then,
I can open the rooms when you're ready, Abby.
okay, yeah, I think we're ready. I was trying to navigate to it and could not find
Okay.
that far.
All right, I'm gonna go ahead and open the breakout rooms. If you're not able to make it to yours, just let us know. We can help you get in there. All right. 10 minutes, Abby, right?
Yes.
Okay.
Yeah, I maybe
Okay.
could 15, but that's okay.
They're all open. Okay, so if you're still here and you don't have a room, you should be able to click on one and enter whichever one you want, but please just let us know if you need help getting there. All right.
From using Midjourney and then two other programs, that a sign of AI generated art is an overly full frame. So that's what Michael had said, because we were all noticing and thinking of your outer space image, Abby, that it was just stuffed with things.
Yeah, I think that is definitely true in my experience. Yeah, that it wants to put everything it can think possibly fits what you said in there. Does anybody else have anything you want to share? Anything cool you found?
I
Well,
kind of go ahead, Carol.
this is just a quick little bit. And so I added to group 5's little space on the document a link to a Hugging Face space called Laura the Explorer. And it's just a fun little, it actually doesn't work very well. Let me start with that. It doesn't work very well, but it is fun for imagining different artistic styles to apply in image generation if you want to use it in a more effective model. So you can use like, I don't know, think of like your image in the style of The Simpsons or as a Lego cartoon or something. Anyway, that's all I got.
Cool.
Because ChatGPT it does have sort of a default style. You know what I mean? Okay, I'm finished.
Yes. No, I think you're right that in general too, people like have preferences where I think GPT is a lot of times praised for its realism versus Midjourney is more praised for like drawings, or people have preferences for what they think each does better. And it seems like the different ones kind of have distinct different art styles. So that's also cool. A lot of times you can ask for an art style, but I think certain things will be like, especially GPT-4 / Dolly will kind of, you can ask for specific things and it'll be like, I'm not allowed to like know that. So if you're like, paint this like Van Gogh, it might be like, I can't really do that for you. So a lot of people have been trained models to sort of accept specific styles. There's, of course, always with image generation, the sort of icky side of it that, of course, people have trained models to copy specific living artists' art and just essentially create what a living artist could have created on their own, and then that's no good. But there's lots, you can find lots of like sort of specifically fine-tuned models, yeah, especially on Hugging Face that do some pretty cool stuff. Okay. Does anybody else have anything that they want to share?
I had a particularly hard time with Dream Studio. I wanted to make I really like the idea of the negative prompt, like please don't do this. But I spent most of my time trying to make a bicycle with Parmesan cheese as its wheels, and it just would not do that. Like, it's very easy concept, right? Parmesan cheese comes in round things, and it just won't do it. It would put the cheese at the top in the basket, no matter how much I would tell it, please use round wheels of cheese as its wheels, do not put normal spokes. And Yeah, I just couldn't do it. So yeah, I don't know.
That
This-
is very interesting. Yeah, I, like you, would have thought that that would be a relatively simple task. The negative prompt is interesting. Like, I don't know if even just putting like bicycle wheels in the negative prompt, I mean, you might have tried that. The negative prompts do kind of allow a bit of like specifically trying to like get stuff out of your image, but it doesn't always work. And sometimes it really just
Yeah.
has ideas of what things look like, and it really just wants to make that for you.
Yeah, no, I'm quite disappointed now. But
No.
anyways, yeah, that was cool though.
Okay, let me go back to, so I will share just kind of some, I don't even know if they're best practices, but what sort of I have found with prompting can kind of be good ways to structure prompts, to sort of, if you have a specific kind of style or piece in your mind and you want to sort of get things to look a certain way. So I'll start by kind of showing an example of, let's say I wanted a drawing of a dystopian post-apocalyptic cityscape. And if you're familiar with the game Fallout, the Fallout series, Fallout New Vegas, that's kind of what I had in my mind that I wanted this to create. Which, if you know anything about that series, it's a very, the idea is it's a post-apocalyptic world that's very kind of like dark and grungy. But then there was like a city that was kind of rebuilt on top of it. So it has, I guess, almost like a cyberpunk sort of vibe to it. I mean, it's very like that high contrast between like a dark, dusty, post-apocalyptic world with like pops of color. So that's what I had in my brain. But I just asked for a dystopian post-apocalyptic cityscape. And this is what it gave me. So this is a really simple prompt, but you can kind of see that if I don't specify exactly what I want, this is sort of the type of thing that it comes up with. And so I had iterated on this prompt for a while, and then this is the prompt that I sort of came up with that ended up giving me something much closer to what I was going for. And you can see that there are a lot more words in this prompt, but I still start with a dystopian post-apocalyptic cityscape. I just go on to specify like a lot more things. So I specify the perspective of the image, kind of where I want it to be looking. So I want to be looking above and ahead. I specify that I want debris on the streets. I want it to be reminiscent of Las Vegas. I pick a concrete thing I think it probably knows and say you can make it kind of look like that. I say how it should feel. So I want to feel desolate, dark, moody. I want specifically pops of neon color. So kind of all of these things I am specifying here. And so I'm not saying this is like the gold standard of prompting, but in my experience, this is kind of a good example of just kind of all of the things that you might want to say in a prompt kind of in one place. And so I went ahead and took this prompt and sort of, I don't know, categorized it into sort of what I think are like the main important or sort of dimensions of prompting that that seem to really be good to include in a prompt to one of these models. So the first thing in green is, of course, concrete and specific objects or subjects. If you want specific things in an image, then you should say those things specifically. And sometimes repeating yourself is helpful, and sometimes describing those specific things in more detail is helpful, but really just saying what you want in the image. In orange here, I have image logistics. You can kind of say things like you want it to be a drawing versus a painting versus a HD photo. You can specify the perspective. You can specify exact colors or the extent of the color palette or just kind of any logistical image thing. Adjectives and descriptions, it tends to understand pretty well. So, you know, partially destroyed, abandoned, dystopian, all of those things are kind of adjectives, but that have pretty concrete meanings. And so all of those are good to include. But you can also include things that are more abstract, emotions, concepts, atmospheres. I find that a lot of times just saying that it should like feel lonely, like although it doesn't grab abstract concepts quite as well, within the bounds of the model's creativity, sometimes saying that and then generating like 5 or 6 images is the difference between getting what you want within 5 or 6 or not including that and generating 20 images and like never seeing what kind of felt like it was what you were trying to achieve. So it does have some understanding of stuff like that, but this is kind of, it's going to be a little creative with that. And then of course, those negative inclusions, you can totally specify what you don't want. And that can be really helpful, especially if it, you know, if it just keeps putting animals somewhere where you were just trying to get like people or something, then you can always be like, I don't, just like stop doing that. And a lot of times it will pick up on that. Sometimes it won't, but a lot of times it'll pick up on that. So that's just kind of an example of kind of dimensions that I think make sense in a prompt. And they don't necessarily have to be in any particular order, although I do tend to put my negative inclusions last. I think that's just a personal preference. So yeah, are there any additional questions about prompting, about anything related to this?
If
Or
I could
something?
just,
Yeah.
I'm sorry, if I could just pop in here real quick, another interesting prompting method that I've seen, especially with ChatGPT 4 being able to like converse with it about the image, is asking it to generate multiple images and then choosing the style that you like and saying, how would you describe this image, ChatGPT? And then it will put out a pretty neat description that you can then use to get the qualities that you either liked or didn't like, and then use that to kind of iterate over your prompt.
Yeah, and GPT-4 is actually a really interesting one because the prompt that it, so like it has the whole conversation happening in the chat. And what it's actually doing is like distilling that into a prompt and then sending that to make the image. So you can have this whole, like you can say this whole long thing, you can get this, you can converse and iterate over and over and over again. And obviously that's much longer than like one image prompt, but ChatGPT will tell you what ended up being the prompt that it gave. So there is an amount of like distilling versus if you're in like Midjourney or something, like whatever you type into the box is the prompt. But it is, I think, another thing that I just love about DALL-E through GPT-4, because I also really like to like, instead of rewriting my whole prompt and sticking it back in, like it's cool that you can be like, oh, I don't like the building in the middle. Like, I don't want any big buildings, you know, and you don't have to like rewrite your whole prompt to include that concept. So that is very useful when you're playing around with this. Any other questions, comments, concerns? Okay. Well, then I think I will end there. I can show you like ControlNet or something if someone has interest, but we can also maybe move that to office hours if that's a bit more kind of nuanced.
All right. So it looks like we're going to finish up just a few minutes early. Is that correct, Abby and Miranda? Anything else we need to cover before we end for today? Great. All right, so remember that we will have office hours immediately following this. So if you have specific questions, these could be questions about things that we've been covering during the workshops. It could be any question about AI, any research you're interested in doing with it or using it in your research. So you can use that office hours as sort of a consult time as well if you'd like. All you need to do is just stick around and then ask your question. Also do know that we're open for consultations outside of this time as well. So you can sign up for a half hour, for hour time with me or with the Sharo, or with a number of us together. In particular, we want to support Vanderbilt researchers, Vanderbilt University and University Medical Center researchers, students and staff. So yeah, so stick around if you have anything for office hours. Other than that, congratulations on finishing day 2 of our AI winter, and we will see you tomorrow.
Jesse, I actually have a question.
Yes.
So Liz and I were talking about the amount of information that we can put into one of these models because, so for example, if we have, like Melissa was talking about qualitative data, and so was Alyssa. So just thinking about qualitative data that you put into these models to, like you and I were playing around looking at sort of categories and themes that were generated through, mock data. If like how much would be too much to put into these? So for example, if we were playing around with an Excel file, and could you dump portions of an Excel file in that had identifiers that would like categorize different responses? How much is too much to put into something like GPT-4?
So with the GPT-4 with the 128K version, that is that's going to be about 350 pages of like typewritten pages. So it's a fair amount. And whenever you're doing work like that, we were saying summarize, pull up, sort of do work across the entire document. That's exactly when you want to have it in your context, right? You want it all in your context all at once, because it's going to need to sort of look across the document, especially if you're doing like find what the topics are, then that's sort of a holistic kind of work, right? So anytime that the work involves the entire document, summarization, synthesis, anything like that, that's when you want to have it in the context. As opposed to something where it might do to have it just the document uploaded and to have it chunked and then to be able to do that with you. And sort of the in-between one is you're asking it to help you write code against something that will be run against the documents. And that's one way where you can do a lot more and with huge amounts, because you're just writing code. This could be Python, it could be SQL, anything like that, where you are working with the document sort of separately. That's a different thing. Just wanted to separate those things out. But if you're just interacting with the entire document of documents all at once, that's when you want to have that context link. 200K for Claude, for which we do not have an agreement, right? But that's like 500 typewritten pages. 128, a little bit in between there. And there are things you can do to sort of narrow it down a little bit. Like there are fields that you don't need. You don't have to put those into context, right? And there was some concern early on that maybe with the long context models, it wouldn't do as well pulling out details in the middle. That turns out not to be the case, though. You do have to be careful with your prompting, but there's a fair amount of space. So you're talking 300 pages of text, and those could be in the form of tables, but you might need to reformat them a little bit. And so it's more text-like. It doesn't natively in context work with tables directly, but it can understand the structure of, right? If that
Okay.
kind of makes sense. Yeah.
Great, thank you.
Yeah, absolutely.
Can I throw something in, Andrea? Because I mentioned it came to my mind yesterday when you were talking about this, and this is going to be too deep a dive, so Jesse, stop it when you want. But thinking about what you're trying to do, which is qualitative analysis that Melissa and I were talking about, and this goes back into an area of my research. What people say on the face value as topics isn't necessarily always and only the things they mean, and so I get a little worried with the idea that we're just going to say pull out meaningful themes without starting to think about careful prompting in terms of different models of how you might understand the meaning of discourse. And I don't want to go too much on the qualitative side, but if you understand, looking at the same corpus of text from a narrative lens, a discourse lens, I don't know if Melissa's still here, many more others would produce different things. And I think that for this context may or may not matter, but I think there's something very important there, if that makes sense.
I think that's a great point. And the areas that we're looking into in some of the projects, one of the projects that we're doing this semester is, once the researcher has gone through and has a theoretical framework from which they want to approach this, that's context too, right? So that actual, the white paper that you've written or the guide that you've written, you can say, here's my framework. Now, given this framework, give me, find instances here, or so you can do that. It's not all just, hey, find for me. And it can be everything from that very prescriptive to something which is a little bit in between. I'm interested in answering these types of questions, come up with topics that may be germane, all the way to the, hey, just tell me what they're talking about here, right? And sort of all points in between. But this is like green field, right? This is like, we've only had these long context models, a short period of time, really. And we've had the problem where the long context model up until now have only been available from private companies, and they weren't very good at giving you private access to it. So really, I mean, Vanderbilt just got private access, Andre, we've been talking about this, like now, right? So we could look at more sensitive kind of information. And now we have other models you can run locally on big hardware, but still privately, completely, that has long context as well. So that's why we're so excited to be working with this, because it's like, this is the very beginning of really, which is frankly going to be a remaking of the field of qualitative research.
I think that's really helpful. And Alyssa, thank you also for your comments about that. I think because this is very new for me. So I'm fully, Jesse knows I'm completely open about saying, wow, I don't know, I don't get it, I want to learn. So I think this is exciting. And one of the things that's exciting to me is to, especially if these are closed models, is to think about decreasing the bias and the noise that comes in with analyses and with using this. So I'm pretty excited about it.
Yeah. What's interesting is that, you have, so that especially if you do the, hey, just tell me which topics, it's going to have the model's bias, but it's reproducible, right? So it's not that it's bias free and objective because it's an LLM, it's going to reflect what it's been trained on. So you have to keep that in mind. But at the same time, then you can add other things to the context to address that. So it's almost like different issues. Now you don't have multiple researchers where you're just wondering if they're all thinking in the same way. Now you have one point of contact. It does have trained bias, which is in there, but at least it's something that you can measure, you can rerun, you can validate. It's not like you're paying someone by the hour and it's going to cost you every time you do that. It's going to cost some, but not nearly as much. So if you're interested in whether it's going to be missing something or if it has a particular viewpoint or bias, you can measure it. And you can actually even, there are ways now where you can quantitatively measure as well. So it's exciting to think about that, but all those procedures and methods need to be developed.
Sorry, Jesse, I want to say just one more thing because this is so interesting. There's also two very epistemologically different models of qualitative analysis, and I think understanding sort of what are the established standards for rigor in each and how do you replicate those here becomes very interesting, because the one I think you've referred to a couple times with the coding and categories is sort of this post-positivist triangulation between researchers. But there's a whole nother interpretist tradition, which is the one that Melissa was talking about, that has complete, like you wouldn't expect two people to see the same thing. And so then there's a whole different set of standards. And then in fact, the fact that it's exactly reproducible is actually maybe not an advantage. And then I could start to see you asking it to query taking on personas. Anyway, but then that's the other problem. So it's very interesting.
And even if it's not personas, then it might be, from the perspective, so it might be, again, so it could be an article, it could be a chapter, it could be from this perspective, now do this, from this. So reproducible in that sense, where it's like, it's not, so that's really interesting.
Yeah, I know what you're saying.
Yeah.
But Jesse, that's what I'm blanking on his name. Political science. He was in the session that you had at Peabody.
Yes.
Yeah, and he was talking about using personas to
but that was generating data, not analyzing it.
Oh, gotcha. Okay. Okay.
Right. Yeah, but that's sort of
Gotcha.
querying the model for, whereas this is, especially if it's all in context, then you know what's there. You're not just going with what's innate, and I say innate, what's been trained into the model. It's like, okay, no, this piece with regards to this, now synthesize. Yeah. I would love to do an AI deep dive on this. And Charo, I think that I think we talked about this a little bit before. So maybe we'll get with Miguel and see I would love to put together sort of a panel of qualitative researchers and like, okay, I mean, like, man, like map out the work. What needs to be done to enable this? Because we have tons of students that like want to do. I'm getting emails right now. I've been answering emails from students saying, "Hey, can I join a project?" It's like, we actually had that session last semester, and we're all, but so there are a bunch of students who want to do things. So,
Well, Melissa and I were talking offline after yesterday that we'd really like to launch something, and specifically, we'd love to get you and Shiro. Hi, Shiro, nice to meet you. Thinking, Andrea, if you're interested as well, because there's a lot more to say, but I think looking especially at the differences, because I know the thing you did with Amanda, it's very different approach. There's a lot of bad language around what we mean by qualitative analysis, but looking at a content analysis and an interpretive tradition, and there's a nice way to map out the 4 different dimensions of what is considered good work. And we could see, how do you hit that from the different traditions? And what does it mean to consider an AI model as, do we consider it as an analyst, or is there other ways to think? Do you know what I mean? Like, that's what we've been talking about, but maybe that's not the only way.
Yeah. Oh, I love that. So we might not even, we might do something a bit bigger than an AI deep dive. And
well, we could partner. Live would be really interested, honestly, to do something like that if you want.
And I think a starting point, I think even just laying this out, I mean, I could see a really nice paper, laying out, okay, here's where we are, here's what we have for and then, following that, what are the, methodological considerations on the AI side for the methodological, this is, for the different traditions as well, which I love that. Okay, great. Let's talk. Other questions. So open office hours here, and also do know that that we can also go into breakout rooms if we need to. So if you have a specific question, and one or more of us can go off to a breakout room as well. What other questions do you have?
I have a little question. I found that some of these image models just don't seem to have references for like very specific topics. And like, for example, I was trying to make it draw a mouse brain, which I'm pretty familiar with, but I don't know if it's been trained on a lot of mouse brain images. And I was just wondering if we're going to get into any of something like how to add images into a custom image model or anything like that, or yeah.
No, that's a great point. Abby, do you have some initial thoughts?
Yeah, I mean, okay, so I don't know a lot about mice brain, but I think my initial thoughts are that I definitely think the model's strong suit is more creativity rather than needing specific information, like specific, although it's hard to say because with concepts it does know very well. It can give kind of reliable, like people that it has seen lots of instances of. So I'm guessing it hasn't been trained on a lot of mice brain, and that means it doesn't have concrete enough of a understanding of what that looks like to reliably generate instances of it.
But you could do things like, imagine, you have an atlas, right? A wireframe atlas of a mouse brain. You could use what are those called? Control nets? Yeah. So you could use guided visualization. So it's like, start with this, or stick within these confines, or even modify this image to another. So anything from starting from an image, but now change it in this way, to here's an outline of what I want, or here's a sketch of what I want. now make it the mouse brain. And a few steps from that might be, here's an outline, here's an image, move one to the other, so there are ways of doing it. And of course, then you could do additional training of these models as well. I mean, you can, if you have the images, you can train it, and so it knows that better. What it will learn about those, whether that will be correct, it's hard to say. Think about them as very powerful learners of distributions, right? And that's actually what all these models are doing, but especially with diffusion models, they're powerful learners of distributions. But guiding them is the tricky part. But we're getting to the point now where you can use diffusion models to actually generate like computer code. So it's not just images. Diffusion models, that process of noising and denoising, can be used in more and more areas. So I think we're probably going to be seeing more. If you can generate code using diffusion models, then that means that you can generate, much more constrained types of all sorts of things.
And I'm also curious to know, what kind of mouse brain are you thinking? Like, is it like a creative sort of mouse brain, or what is the purpose of generating this image of a mouse brain? Is it meant to be like very specific, like academic, or is it supposed to be like, look at Tom and Jerry's, a brain? What kind of application are you thinking for it?
I guess originally it was just kind of a, I was curious to see, because after a while of playing around with Dolly, I was getting the sense that, okay, it's really good at some things, like, and it's other things it's not so great at. So I was kind of having fun. The original idea was like, just make a quick little figure instead of like going on to bio render or drawing my own mouse. Because a lot of figures it'll just be like a mouse silhouette, the head, and then like a sagittal view of the brain. But the original idea was just quick figure generation. But then like for actual science stuff, this is probably down the line, but it would be great to have it, feed it an image from the microscope and have it identify like, oh, this is this part of the brain, this is this part of the brain. And yeah, just no real definite plans yet, but just kind of brainstorming. Oh. But yeah, I do have a ton of images I could potentially try to feed a model and teach it. I just don't know if that's feasible on like a local computer, or what that whole process is like.
Well, that's an interesting question. The state of the art has moved forward a lot faster on the training, parameter efficient fine tuning and training of transformer models. For diffusion models, have you looked into that at all, Abby? Training of diffusion models?
Not really. Yeah, I mean, yeah, the only thing I can think is if you could, just get away with like retraining that UNet part, and especially if it's in the latent space, like it's not that large of a model, so maybe that could happen locally. But I haven't looked into it specifically, so I don't really know.
So Nick, I would suggest, so we have, as the semester begins, we're going to have what we call AI Fridays. So from 10 to 12, we have drop-ins, and this is going to be our the DSI space, which is in the building formerly known as the Sony building. And are you a Vanderbilt, Nick?
Yeah, I'm at
yeah.
Vanderbilt.
Great. So it's the Sony building. It's now it's called 17th and Horton building, but we're right there. And from 10 to 12, you can like drop in. We can pull up. We can do some research together. See what the frameworks look like. Like we just Miranda just found a great framework that's really new for training these large language models. And who knows, we'll have to check and see if they actually have anything for training the image generation models. That's possible. Great. Other questions? Yeah, Michael.
Thanks. This has been wonderful. I'm looking forward to tomorrow and Friday. I saw that the book you referenced yesterday was a 2022 copy of natural language processing. I ordered it. It should be here tomorrow. Any other books or articles you can recommend to so that I can take what I learned here and then dig into it on my own?
Yeah. Give me a little bit idea of your background. Have you math or programming? Is that sort of your orientation? Because it sort of depends on sort of your background of what's
Sure.
best.
Sure. Yeah, great idea. So my background is actually in philosophy.
Okay.
I study how clinicians use the clinical record to construct patient safety and improve clinician well-being. So I look at documentation burden. Right now, I'm writing a grant to see how the use of AI is going to affect clinician behavior. Dan France on the call is one of my mentors. So that's what I'm looking at. In my AIMS page, the feedback I've gotten from DBMI, Biomedical Informatics, is that I'm ahead of what VUMC will allow me to do with AI. So I need to write a framework to apply it to current EMR systems and then test it in a high fidelity scenario using AI. So that's my background and what I'm working on right now.
Okay. And have you so we have a colleague, so I was just at AMIA for and we did a workshop. Dr. Yakuma Crystal, have you chatted with her? Yeah, and you know, so she's as a good colleague there at VUMC to sort of to chat with as well.
I actually don't know her. It looks like Dan knows her, but I have not met her.
Yeah, I can make that introduction. We also work with Lori Novak, who's in DBMI, and she's thinking about all these issues with AI as well. So I'm happy to introduce you to her, Michael. That's a great recommendation, Jesse.
Yeah, no, that's great. And and Lori Novak, that's fantastic. So yeah, you know, there's so for papers, I'm going to go and give you one paper, which is actually kind of, it's one of my favorites. It's more mathematical, but I would sort of use this also. And Michael also mentioned it, and to anybody here, I do welcome people to sit in on my transformer class, which is Monday and Wednesdays, 3:45 to 5 this coming semester. I'm going to share with you a paper that I use that I teach in the first part of the course. It's more mathematical, but boy, it's like a very concise statement of what the models are doing. And then I might have to give a little bit of thought about sort of what would be a nice overview, because it's shifting so quickly. It's tough to get something that's not immediately outdated. But here, I'll look up a paper and I'll put it in chat right now, just for something for you to use for like a great, you know, overview of the architecture of these models.
That would be great. And I'll send you an email about how to get registered or, you know, survey your class as well.
Fantastic. Okay, great.
Thank you. Thank you all for your patience as I learned here.
Now, this is exactly what all this is for. So this is perfect.
I have a really general question. I'm very late to the game in AI, but I started to do the courses that Jules White has on Coursera.
Yes.
But I'm also in VUMC, and VUMC, as you know, has a HIPAA compliant version of kind of ChatGPT.
Yeah.
And some of the exercises in Jules, his courses require you to upload documents and such, and we can't do that with the version we have in VUMC. So do we need to go out and get a subscription version, like on our own home computers, or is there a workaround that you're aware of?
Yeah. So, you know, Jules has developed a very nice front end to sort of assist with this. And you're right, on the VU side, we now do have GPT-4.
Okay.
And he has, so I'm hoping, and maybe we can actually help with some of these conversations. I think it'd be a great idea if VUMC, because we're both using the Microsoft Azure approach. I think we have a bit more access to GPT-4 than VUMC does right now, but there's nothing. It's just a matter of like negotiating for it, right?
Okay.
So to that end, yes, you could do your own version. Do know you're uploading the papers absolutely to an unprotected area. So it'd have to be just like, if you did the Chat GPT, $20 a month, just know that it's going to be, they may not train on it, but it's certainly sitting on their computers. And we know that they've had trouble with leakage. So we are going to be talking about on Friday, briefly, a way to set up, perfectly secure ways of running local models and doing sort of local work, even with RAG. This requires more of an investment, right? This is more like you got to have people who know what they're doing, who can program this, who can do this stuff. But then it's running on your own system, maybe on-prem, and that's completely secure. So depends on how far you need to go with that.
Right.
I hope that helps some.
Yeah, that helps a lot. Yeah.
Okay.
I just wanted to make sure I hadn't missed something else, but that's helpful. I know this is developing really quickly, and I'm in a weird situation that I have faculty appointments on both sides, but I really want to follow the VMC. My primary is in VMC, so I try to just stay with what their policies are and such. So, but as Michael said, a lot of our research it's moving faster than what is allowed at VMC. So we're gonna have to do a lot of this like in a simulated environment and such like that. So, but we'll just stay connected and we'll move along with you guys. So.
Now, the other thing that we've been talking about too is creating a VUMC blessed area for storage to create access for our DGX A100s. That's especially useful for for further training of these open source models. Like you can imagine, like Mistral, Llama being trained on medical records, for example. So know that those are conversations we're having as well.
Great, that's exciting work.
Yeah. Great. And Michael, I put just a paper there, again, more technical, but this is kind of like a very brief synopsis of like, this is exactly what the models are doing. And it may not be, so that's something which is great to keep in your back pocket, because if you can, and like I said, in my class, I do spend a bit of time going through that.
That's great. I actually have a mixed methods background and a certificate in advanced quantitative methods. So
and this is going to be your language.
Okay.
This is like, I think you'll feel at home with this. If you're able to sit on the class, we'll be able to talk it there, but also know that, AI Fridays, you're always welcome to come by, even just to talk about that if you'd like to.
Awesome. Thanks.
Absolutely.
It sounds like you're interested mostly in natural language processing. Hugging Face Transformers has some nice documentation on this, but it's more expansive than that a little bit. And it is about like audio, it's just about transformers in general. Also, so beyond just like NLP and audio and image, all that great stuff, it also does not just focus on generative AI. So it focuses on the entirety of transformers. So as we were talking about before, the two halves. And so that might be just a little bit more than what you're trying to like learn about. But their documentation, I'll send you like one of the pages and you can go down the rest in the sidebar. It's pretty accessible. And so it might be something nice to just read through.
That would be awesome. Thank you. Our current project is using natural language processing. After I've collected the data, we're moving into that. So yeah, super helpful. Thank you.
Other questions?
Jesse, I put this question in the chat, and with your generosity with sitting in on your class, maybe that's the primary method, but do you have a core, or is there a fee to consult with you guys on projects, or
So actually what, no, we have, open consulting, and with the aim that often, this involves our master's students getting real world, we will have some opportunities in the coming year for more core-like services, especially around our postdoc. We'll be hiring additional postdocs, and so that's one possibility. But really the consulting, especially like the AI Fridays dropping, it's just like, that's open door. And then we have, you can sign up for consulting hours as well. That's meant to be more of a one-time, per project, right? I'm thinking of this project, would like to sort of figure out how this may work, versus methodological, right? So, with the biostats core, for example, that's, it's very different from that. This is more like once per project, come and, have a, specific consult, and then we may spin up a research engagement. But OpenAI, I'm sorry, the Friday, AI Fridays are like, anytime, 10, Fridays, 10 to 12, in any week.
Awesome. Thank you.
Absolutely. Carl.
Yeah, I have a question about the Python R debate. And does it, okay, for context, Jesse, I was in your class last fall, and I think everything that I observed, at least, and like in the NLP textbook, for example, uses Python.
Yeah.
Right. I'll be in a class this semester called Behavioral Data Science, which I'm very excited for, with Alexander Christensen, and he expressed interest, I think, in also transformers being applied to this kind of, to whatever's going to be covered in his class. I was wondering though, like, to what extent is R all equally sort of compatible with different transformer models and their uses and things. Yeah.
It's not a strength of R.
Okay.
So, I have used both, and, for years, R was my first go-to language, especially for working with data analysis, exploitative analysis, and certainly statistical analysis. Like, you can't beat R. It's just, especially statistical analysis is just ugly and painful in Python. But for transformers, training models, the glue which holds things together, it's a first class citizen, and there are packages which allow you to do some things in R. It's not entirely cut off, but they're not going to be the latest. They're not going to be equal. And it's just not as well developed as the Python. Plus, it's very especially for in the tidyverse, the kind of stuff that you're doing with transformers is very non-structured, unstructured, and you're having to interface with a bunch of external processes and programs, and that's just not something that's a strength, especially the tidyverse, right? So you can do it, but it's, yeah, I have not seen any strong development, especially with newer packages. But the fact is that being able to generate code now is so much more straightforward that it almost matters less what language you're in. So the R that's written by, you'll find a lot of these code generation, these code specific, like Code Llama was trained on Python. You're not finding models that are trained just on R, but they can do R, it's just not as good. So my question would be, what do you want to do? Right? If you want to do statistical models, absolutely use R. You know, if you want to be training traditional machine learning models, random forest and and the like, then quite possibly R. They have a very nice package for that. If you want to be doing transformers, training transformers, and solving those kinds of problems, Python.
Okay, that's really helpful. Yeah. So it's sort of, it's not an either or
No
decision. Yeah.
It's an and. Yeah.
Yeah,
Thank
I
you.
do. I do want to add that unfortunately there are some universities, one example is UVA, that have mandated that any research that is done at their university uses a common programming language. And unfortunately, they've picked R. And so what that means is, and I'm seeing this firsthand, my girlfriend's getting her PhD in quantitative methods at UVA. All of this generative AI associated programming is being done in R. It is possible. It is very difficult. They pretty much use the reticulate package and pretty much transfer over a Python package and run it.
R.
It's R, but they're really running Python under RStudio, which is quite annoying. It is possible. I've seen them use it and it does work, but it is extremely frustrating to me as a Python user who's seeing that, okay, you can call the OpenAI API using one line of code, or you can use Reticulate and use 10 lines of code and do the exact same thing. It's totally possible. It really boils down to what your university guidelines are surrounding it. And if it is R, I'm not going to say it's not possible. It very much is. It's just difficult.
Okay, sort of a follow-up question. What if, I don't know, I don't have an example offhand, but what if I have a project and I want to be using statistical modeling, and also I want to be training a model. So, and so how well do R and Python really communicate with each other?
So,
or am I asking the right question? I don't know.
So my mind is going to when do you want them to communicate? Right.
Right.
Yeah. I would not try to be doing all the model training in R and then communicate. I would if you're doing model training and maybe even calling models, maybe you want to do that in Python and then produce, maybe you have a process that goes and it produces JSON objects for you, which are then processed in R. But if you can keep that communication clean, inter-process communication can be ugly. If you do inter-process communication, then be sure that you are using oh my gosh, I can't believe I'm forgetting the name of this. The cross-program communication. Do you know what, Imong, you know what I'm talking about? I championed them for years and I'm forgetting the name of it because they changed their name. There is a way to do clean cross-process communication where you don't have to serialize and deserialize. If at any point you're having to serialize and deserialize, if you're having to pickle something to move it, don't do it. Do it a different way.
Jesse, I think you really nailed how it matters when you need to have this data or these pieces of software communicating. Because I think what Miranda will show us tomorrow, it runs on a server. Maybe I should leave that conversation to her. But that means that you might be able to access that trained model or whatever have you in R without having to use the Python part, except for to do the training of the model. So again, it just depends on when you need to use what, and if you need them to kind of converse or interact in the same exact moment. So,
yeah,
just communicating data versus inter-process communication. I'm sorry,
yeah.
Mom.
Yeah, sorry. You can interact with the models in R relatively straightforwardly, but training is just not an option enough.
Got it.
You just won't be able to do it.
Yeah.
Thank you.
Excellent. Other questions?
Do you think Apple's new MLX machine learning framework is gonna be a good investment to start learning, or
It is.
just wondering what your thoughts are on
Yeah.
that.
It's too early to say. I've just started to take a look. I thought it was really interesting. The new model that they've just released was actually trained on the GGX A180, which is not, it's a significant piece of hardware, but it's not like, oh yeah, we use 500 Google TPUs to do this, right? It's kind of like, so it's very efficient. I was very impressed that they were able to do that. They've been working on it for a while, but and again, it depends on what you want to do. If you want to be able to run and to use their on-phone neural net chips, it's going to be a very good idea to do that, because natively it's going to be able to generate that code and to do that for you. If you want to do just like general models, I'm wondering what the value proposition would be. So they really need to build up a lot more. There's so much going on in the space. What do they have to offer that would be so much better that would make you want to commit to their infrastructure, especially considering how sort of closed they like to keep their infrastructure. So I am a little bit skeptical at the moment, but that's just me. Iman, you've worked with Apple for a while. What are your thoughts?
Yeah, I'd say if you're planning on developing Apple-focused products and you plan on using their chipset and architecture and machines, and that's the primary place where you're planning on using, then yes, totally. But apart from that, I do think that it's going to be something that's very, very closed off to the Apple ecosystem. So if you don't plan on making something that's accessible to, Windows users or whatever else, I think it's going to be very, very Apple centric, and more specifically Vision and iOS centric. Like that's going to be their priority, is kind of taking AI and putting it in the vision space.
Gotcha. Thanks.
All right, other questions? All right, we might finish up just a little bit early then, unless anyone else has questions. All right. Then we'll see you all tomorrow. Look forward to tomorrow's session with you. See you.